Hi guys, today we're going to talk about quadratic vocabulary first. So we want to make sure that we know where these solutions are that we've been finding, and we want to know some of the other key features of the graph. So this is just a review at the beginning, and then we're going to talk about equivalent quadratic forms. So there's standard form, which you're familiar with, but then there are a few other forms that you also need to be familiar with. And so we're going to talk about those key features and where they appear in those other forms. So the solutions, or roots, or zeros, or x-intercepts that you have been finding are giving you the location of the x-intercepts. If your graph is opening down, then they would be here. One of the other key features that you want to know is the vertex. Remember, the vertex is where the graph starts to change direction. So in this first parabola, the graph comes down and it hits about right here before it starts going back up again. This is the vertex. Same thing here, your graph goes up, and then about right here it changes direction and it goes back down. And this is also the vertex. Now the vertex can be either indicating that the graph has a maximum value or a minimum value. So you want to see where the vertex is with respect to the rest of that graph. So the vertex is down here, the rest of the graph is above it. So that means that this vertex shows you that the graph has a minimum value. And this minimum value would be written as y equals and then some number. So it's giving you the y value right here of the vertex. Now on this one, if your parabola opens down, then your vertex would indicate that you have a maximum value on your graph because this point is higher than all of these other points. So this point right here shows you where the maximum, ooh, that might be too many swirls. There we go. Maximum value. And you write it as, again, y equals a number. So your vertex is showing you where the highest y value is. One of the other things that you need to be able to identify is the axis of symmetry. Now the axis of symmetry goes right through the center of the graph, and it also coincidentally goes through the vertex. Now the equation for that axis of symmetry is going to be x equals a number, because you're trying to figure out what x value this vertex has, and that's the center of your parabola. So we're going to talk more about the axis of symmetry in a moment in our official notes today. And then the last thing that I want to discuss with you is the y-intercept. So in these parabolas, the y-intercept is not really clear. So, but I know that this parabola is going to go up, 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 and it's going to cross somewhere, maybe up here, maybe even off of my page. Same thing here. I know that this parabola doesn't touch the y-axis right now, but if I were to continue drawing it down, 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 it would cross somewhere down here, and that's the y-intercept. And you write it as 0, comma, and then your y value. So this is just a review of some of the basic key features that we have for quadratic functions. So today we're going to use that knowledge and our knowledge of solutions and algebra, and we're going to talk about equivalent quadratic forms. So the first essential question is, what are the three forms of a quadratic equation? So there are three forms we're going to discuss. And then the second essential question, how do we find the key features and graph from each form? Okay, so you're familiar so far with standard form, right? So standard form is what we want our quadratic equations to be in if we're going to factor, if we're going to use the quadratic formula, if we're going to try and find the discriminant to determine the nature of the solutions. So y equals ax squared plus bx plus c, that's standard form. Vertex form is a little different. We still have a out in front, but then we have x minus h, and that quantity is being squared, and then you have plus k, a constant outside. This h and this k are a little special. More on that later. And then finally, we have a root form or factored form. This is something that might seem new when you're looking at it, but whenever we do problems, you're going to realize that it's actually something that you've done before. So root form or factored form is the third form that we're going to discuss. So for standard form, this should have a x squared, not a squared. So you might want to fix that. If a is positive, then the parabola opens up. So it looks like that first parabola that we had in our notes this morning. But if a is negative, what way does the parabola open? It opens down. It's been reflected over the x-axis, so it opens down. And c in standard form is always going to be the y-intercept. The vertex can be found using this formula, and believe it or not, this is a formula. The x value you can get by putting together negative b over 2a, so over 2 times this value. And then whatever you get, you can substitute that in, and you can get your y value. In other words, you can use negative b over 2a to find the x coordinate, and then substitute this value into the equation to find the y coordinate. So that will give you your vertex. So here's our example today. Trying to make sure it all fits in there. So our example is f of x equals, remember f of x and y mean the same thing. So this is kind of like saying y equals. It's just claiming that this is a function. So f of x equals x squared plus 4x plus 3. My a value is 1. My b value is 4. My c value is 3. So I want to determine which direction this opens. Well, the parabola opens up if the a value is positive, and it opens down if the a value is negative. Well, my a value is 1, so how does this open? It opens up. The y-intercept, how can I find the y-intercept? Just by looking at the equation. Well, the y-intercept is c. I write it as 0, c. So my y-intercept is 0, and then my c is 3. So these are things that you should be able to just immediately pick out of standard form. And it takes practice, but you should eventually be able to just pick them out. Also, on a side note, when we talk about linear functions, we talk about y equals mx plus b being slope-intercept form of a line. And remember that this plus b, that's the y-intercept for a line, right? And so it kind of makes sense that we have the c value being the y-intercept for a quadratic when it's in standard form. So that's just a connection that I'd like you to make. And then finally, let's talk about the vertex here. So the vertex can be found by the formula negative b over 2a. And then whatever you get for negative b over 2a, find that function value for it. So let's talk about negative b over 2a. This would be negative b, which is 4, over 2 times a, which is 1. This is negative 4 over 2. And negative 4 over 2 is just negative 2. So that's my x value. But now I need to find my y value. So I'm going to take negative 2 and I'm going to substitute it for x. So I need to find f of negative 2. Remember, in function notation, if you find f of negative 2, that means you replace all the x's with negative 2. So instead of x squared, I have negative 2 squared. Instead of plus 4x, I have plus 4 times negative 2, and then plus 3. Negative 2 squared is 4. 4 times negative 2 is negative 8. So this is 4 minus 8 plus 3. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So there's my vertex. My axis of symmetry is going to be x equals, and then looking back at my key features, remember your axis of symmetry is x equals the number for the x value in your vertex because it goes through your vertex. So if you take that x value, it's going to show you where your axis of symmetry is. So x equals, this is my x value, negative 2. So now I can go put all of those things together on my graph. I know that my graph opens up. I know that my y-intercept is at 0, 1, 2, 3. I know my vertex is at negative 2, negative 1. So negative 2, negative 1. My axis of symmetry is right here at x equals negative 2. And remember that quadratic functions have symmetry. So if I have a point distance of 2 to the right and up 1, 2, 3, 4, then I should also be able to have a point 2 to the left and up 1, 2, 3, 4. Now, something that we haven't talked about in these notes yet is where the solutions are, because I don't just want my parabola to cross the x-axis wherever. I need to figure out where my solutions are, which means I need to factor. So I need to find my solutions based on factoring. If I factor this if I factor this quadratic, a is 1, so I'm just going to find my magic numbers. I need two numbers that multiply to give me 3 and add to give me 4. What two numbers do that? 1 and 3 do that. So my factored form is x plus 1 and x plus 3. And my roots are the opposites, x equals negative 1 and x equals negative 3. These are my roots. So if I plot x equals negative 1 and x equals negative 1, 2, 3, that looks like it falls in quite nicely with the parabola that I was graphing. And this is the graph of my quadratic equation. Okay. So for vertex form is new. If A is positive, again, the parabola opens up, and if A is negative, the parabola opens down. That indicates a reflection. If A is negative, we would reflect over the x-axis, and that's what would make it open down. But the point h, k is very special. The point h, k is the vertex. That's why this is called vertex form, because you can just pick out the vertex right away. To find more points with an S, pick other values of x to substitute into the equation, and you'll get their corresponding y values. So let's talk about the way that this opens. I see my a value out here is like 1, and it's positive, so this opens up. My vertex is here and here. But look at the formula. The formula has x minus something here. So in order for this to look like x plus 2, What do I have to subtract? I don't have to subtract 2 because that would mean it has different signs. But I would have to subtract negative 2. So notice how the formula has minus something. You need to take the opposite of this number right here, and that will be your h value. So negative 2, comma, negative 1. Remember that your axis of symmetry goes straight through your vertex, so you want x equals the x value of your vertex. That'd be negative 2. And then your y-intercept. Your y-intercept is not necessarily negative 1. Because if you were to take x plus 2 and multiply it by x plus 2 by using FOIL or box method, you would get another constant that would have to combine with this. So what you need to do in order to find the x-intercept is you need to substitute 0 in place of x. So 0 plus 2 squared minus 1. 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So there's my y-intercept. And I can go ahead and plot all of my information. So it opens up. My vertex is at negative 2, negative 1. My axis of symmetry goes straight through my vertex at the line x equals negative 2. And my y-intercept is at 0, 1, 2, 3. So I can find other points. I can reflect this over, that's perfectly fine, but I could also substitute more values into my formula or my equation, and so I'd like to show you that right now. So let's say I want to find when x is negative 1. So when x is negative 1, I'm going to substitute into the formula negative 1 plus 2 squared minus 1. Negative 1 plus 2 is 1. 1 squared is 1. And 1 minus 1 is 0. So the point negative 1, 0 is on my graph. This is looking familiar, isn't it? What about if I wanted to find, I don't know, negative 5? When x is negative 5, so 1, 2, 3, 4, 5, this next point that would be over here. If I wanted to find that, I would substitute negative 5 in place of x. So negative 5 plus 2 squared minus 1. Negative 5 plus 2 is negative 3. Negative 3 squared is 9. And 9 minus 1 is 8. So I would graph the point negative 5, 8. So you can kind of see how we can get more points on our parabola. Okay. And then finally, for this, I do want you to be able to rewrite this in standard form. So I'm going to go ahead and write my equation down here of x plus 2 squared minus 1. If I were going to expand this, get rid of the squared and put it in standard form, ax squared plus bx plus c, I need to write the x plus 2 two times. And then what would I need to do? I don't want the parentheses in standard form, so I would have to FOIL. X times x is x squared. X times 2 is 2x. 2 times x is another 2x. And 2 times 2 is 4. And I still have that minus 1 hanging out there. So my standard form, if I combine my like terms, is x squared plus 4x plus 3, which is exactly the previous problem. So notice how you can, notice how you can rewrite these several different ways. And finally, let's talk about root form. Root form is something that you have really done before. Again, if a is positive, the parabola opens up. If a is negative, the parabola opens down. R1 and R2 are the roots. That's why this is called root form. The x value of the vertex is halfway between the roots. It's halfway between the roots. So if you go all the way in between the roots and you go half the distance, then you'll end up at the x value of the vertex, or the axis of symmetry. You want to substitute this x value into the equation to find the y coordinate of your vertex. And then again, to find more points, you can pick other values of x to substitute into the equation and find their y values. So we have an example. This a value is 1. It's positive, so this opens up. My roots, remember, if this is my factored form, my roots are the opposite signs. So my roots are just what is being subtracted. So that would be the 3 and the 1. So again, you kind of have to change signs here. Your axis of symmetry is halfway between... Oh, wait a second. Who made the mistake? I made the mistake. If this is x minus r1, the first root, then what does the first root have to be? Well, it has to be negative 3. So if this has plus 3, your root is negative 3. If this has plus 1, your root is negative 1, because it would fit in the formula like this, x minus negative 1. And that would make the plus that you see. So I'm sorry for that mistake. I was trying to finish the video so that it wasn't too long, and I made a mistake. So if I plot those roots, there we go. Halfway between them is this point right here, right? Well, that point right there is an x value of negative 2. So my axis of symmetry is x equals negative 2. And my vertex is what I get when I substitute negative 2 into my equation. So f of negative 2 equals negative 2 plus 3 times negative 2 plus 1. Negative 2 plus 3 is 1. Negative 2 plus 1 is negative 1. So this is negative 1. And there's my vertex. The y-intercept, again, you get by substituting 0 in place of x. So f of 0 is 0 plus 3 times 0 plus 1. 0 plus 3 is 3. 0 plus 1 is 1. 3 times 1 is 3. So there's my y-intercept. Still looking familiar, right? Let's find more points. So maybe let's find this next point. So this is an x value of negative 1 and 0, and let's find when x is 1. So let's substitute that in. 1 plus 3 times 1 plus 1. I just substituted 1 for x. 1 plus 3 is 4. 1 plus 1 is 2. 4 times 2 is 8. So there's another point on my graph. 1, 2, 3, 4, 5, 6, 7, 8. Maybe I find x is 4, or negative 4, sorry. So negative 4 plus 3, negative 4 plus 1. Negative 4 plus 3 is negative 1. Negative 4 plus 1 is negative 3, and when I multiply, I get 3. So the point negative 1, 2, 3, 4, comma 1, 2, 3 is on my graph. So that's how I find more points on my graph, by plugging in x values and finding the y values. So if I were going to rewrite this in standard form, well, how do I rewrite x plus 3 times x plus 1 in standard form? Well, I FOIL it, right? So x times x is x squared. X times 1 is 1x. 3 times x is 3x. And 3 times 1 is plus 3. So when I put all of those together and I combine my like terms, I have x squared plus 4x plus 3. So what do you notice about all three of these examples? They all are the same. So they are all equivalent forms of the same quadratic equation.